Now in this question, there is a ring, it's a light ring, and it is hinged at the top point. And there are two beads, A and B. A is fixed to the ring, this is welded with the ring, while this B can slide in the ring without friction. Both the beads have same mass, and the system is released. So B will start sliding, and therefore the ring will rotate, and we have to find the initial acceleration of A and B. Now, in this question, suppose as soon as this and B are released, suppose this ring is rotating with an angular acceleration alpha. Its initial acceleration is alpha. Now, the center of the ring being at a distance r will rotate with an acceleration r alpha, while the point A, this distance is r root 2, A will move perpendicular to this distance with acceleration r root 2 alpha. So this angle is 90 degree. Now if we do components of this, it will have two components. One is r alpha in this direction and the other is r alpha in this direction. So the acceleration of bead A is r root 2 alpha. Okay. We cannot say anything about bead B because it will not move with a ring. It can slide along the ring. So its acceleration can be different from the acceleration of ring. The forces acting on bead B, so say bead B has these forces mg and a normal by this ring, suppose in this direction, and suppose we see the situation with respect to center. So with respect to center, call it C. So it is with respect to C. So for this observer C, the ring is at rest now, and the bead can move along the ring. C itself is moving with an acceleration r alpha, so it will have to apply a pseudo force, that is mr alpha. Okay, so the acceleration as seen by C will be or g, it is g downwards due to this force, and n and mr alpha will cancel out. These two will cancel out because there is no acceleration in this direction, because omega is 0. Okay, so with respect to C, this bead has an acceleration of g vertically downwards. So with respect to ground, acceleration of B will be g due to this mg force, and due to this normal force it will have an acceleration that is normal over mass, and since normal and mr alpha, these two are equal, so this will be r alpha. The value of r alpha we do not know yet, so that we need to find. Okay, now suppose the forces acting on bead A are mg and force exerted due to this ring, and it is welded with the ring. So in general it can have force in any direction, so we'll have to assume forces in components. So suppose the ring exerts a force Fx and a force Fy. With these forces, its acceleration is r alpha in this direction and r alpha in this direction, that we have seen earlier here. So it has two accelerations r alpha like this. So now writing Newton's law, we'll have Fx is equal to m into r alpha This is Newton's law in horizontal direction, in x direction. And we have mg minus fy is equal to mr alpha. This is in vertical direction. Okay. Now we'll consider the forces on rings. So, due to B, ring is exerting a force N on B, so its action reaction will be on ring. Ring is exerting Fx and Fy on A, so its action reaction will act on ring. So these are the forces acting on ring, and since ring is a light ring, its mass can be assumed to be 0, its moment of inertia is 0, so therefore its torque, its I alpha is also 0, so therefore torque acting on it should be 0. So if we find torque about this hinge, then N and Fx, they are along this line, whose perpendicular distance from the hinge is r. So their torque will be Fx plus N into r, and this torque will be in this direction, and it will be balanced by the torque of Fy, and Fy is at a perpendicular distance of r, so its torque will be Fy into r. So these two torques must balance out. So this is the equation we have for ring. So now put the values of Fx, N and Fy we found earlier. So Fx was mr alpha, N was mr alpha, this was N, it was being cancelled by mr alpha, so it's numerically mr alpha, and Fy was mg minus mr alpha. So from this equation we get r alpha equal to g by 3. Now going back, we can find acceleration of A, which was r alpha on one side and r alpha on the other side. So its resultant will be g by 3 root 2. So this is the acceleration of A, while acceleration of B is this is g by 3. So resultant of g and g by 3, so that is under root g square plus g by 3 whole square. So it is g by 3 root 10. Okay.